Einstein's theory of relativity, particularly the special theory of relativity, has implications for the concept of time travel. While it does not provide a direct pathway to time travel as depicted in science fiction, it introduces the idea that time is not an absolute, fixed concept, but rather a relative and flexible dimension. General theory of relativity. Einstein developed the general theory of relativity in 1915. It provides a deeper understanding of gravity, describing it as the curvature of spacetime caused by the presence of mass and energy. According to the general theory of relativity, massive objects like stars and planets warp the fabric of spacetime around them. This curvature affects the motion of other objects, causing them to follow curved paths, which we perceive as gravitational attraction. The general theory of relativity also predicts phenomena such as time dilation in strong gravitational fields, gravitational time dilation near massive objects, and the bending of light around massive celestial bodies. 1. Time dilation. One of the key concepts of the special theory of relativity is time dilation. According to this concept, the passage of time is relative and depends on the relative motion between observers and the objects they are observing. Time dilation means that time passes differently for objects moving relative to each other. Specifically, when objects travel at very high speeds, close to the speed of light, time for them appears to slow down relative to stationary observers. This effect becomes more pronounced as the speed approaches the speed of light. The concept of time dilation has been experimentally confirmed in various ways, including with high-speed particles and atomic clocks aboard fast-moving airplanes and satellites. 2. Twin paradox. The twin paradox is a thought experiment that arises from time dilation in the special theory of relativity. It involves two identical twins, one of whom embarks on a journey at high speed and returns to Earth while the other remains on Earth. Due to time dilation, the traveling twin will experience time more slowly compared to the stationary twin. As a result, when the traveling twin returns to Earth, they will find that the twin who stayed on Earth has aged more than they have. While this scenario illustrates the effect of time dilation, it is essential to note that it does not lead to backward time travel or the ability to interact with past events. 3. Causality and paradoxes. Einstein's theory of relativity does not allow for scenarios where events could lead to paradoxes, such as the grandfather paradox. The grandfather paradox involves traveling back in time and doing something that alters the past in such a way that it creates a contradiction, like preventing one's grandfather from meeting their grandmother. The special theory of relativity does not permit such paradoxes, as it preserves causality, which means that cause and effect relationships cannot be violated or changed by time travel. It's important to emphasize that while time dilation is a real and confirmed phenomenon, traveling backward in time, as portrayed in science fiction, remains a speculative and challenging concept. As of now, there is no known method or technology that would allow us to achieve backward time travel in the way it is often depicted in popular culture. The concept of time travel to the future, however, is related to time dilation and is theoretically possible in certain scenarios.